Hello and welcome to ATI 4448. In the previous session, we started the planning process with forming the team needed to accomplish the project. In addition, we assigned the roles and learned about the contracting process in case we don't have the proper skills available in-house. In addition, we identified project requirements and developed requirement breakdown structure. Then we started listing the activities or the tasks needed to accomplish the project in what we called a work breakdown structure format that can assist in managing the project. Activity duration was one of the important attributes needed to construct an efficient work breakdown structure. To manage the time, we need to go through certain processes as follows. We need to define project activities. We need to estimate the resources needed for each activity to accomplish each activity. We need to estimate the duration of each activity. We need to define the sequence of these activities, then develop a schedule and control that schedule. To define activities, we need to look at the scope baseline to identify project deliverables, constraints, and assumptions. In addition, we need to understand the enterprise environmental factors that might influence the definition of the activity, and the organization's standards and historical information which will help in the decomposition of the activities that will be needed to achieve project goals and objectives. We can also use expert judgment to define certain activities that's not mentioned in the historical data. The defined activities and their attributes will be listed in work breakdown structure format as mentioned in the previous session. Included will be project milestones, and in case you don't know what's a milestone is a significant point or event in the project. After we define the activities, we need to identify the different resources needed to accomplish each activity by saying resources. Actually, we mean people, facilities, equipment, money, and material, not only people. So just to get it clear that resources are people, facilities, equipment, money, and material. The activity list as an output of the first step will be used as an input for the resource estimating process. In addition, we need to look at the current utilization and availability of the resources needed. For people selection, we need to look at the capabilities, the skills, and sometimes experience. There are lots of tools and techniques that can be used to estimate the resources needed to accomplish a certain task, such as, again, we can use expert judgment, we can use historical data, we can use the bottom-up estimating by decomposing activities into a more detailed level. And we can use project management software that can pull the needed resources from a resource pool. The set of available skills will be documented in a matrix. In addition, we can define the set of required skills that are not available within the organization. And that will be used in identifying the contractors needed for these skills, or to fill the skills that's needed or not available in the organization. The list should include uniform listing of the skills and the level of experience in each skill. If the skills are the same, it's supposed to be standard naming or listing or uniform listing, so everybody will be on the same page when we state a certain skill or document a certain skill. As a result or output to the resource estimating process, we can develop what's called a resource breakdown structure. So far, we have a work breakdown structure that will break for us the activities included in the project. We have requirement breakdown structure that will break for me the requirements needed to achieve these activities or the main goal of the project. The third diagram or structure is the resource breakdown structure, which breaks down the resources needed for each activity. This diagram, for example, can be included in the work breakdown structure, but it will be too busy. We can make all of them, like the requirement, resource, and work breakdown structure, be included in one chart or one diagram, but it will be so busy. So that's why we separated them. So we have three different diagrams. We have the work breakdown structure, we have the requirement breakdown structure, and we have the resource breakdown structure diagram. As shown in this resource breakdown structure, the personnel resources are assigned based on the different activities and different employee-related skills. For example, in the design, we need a business analyst, we need a database architect, and we need system analyst. In the program, we need associate program or programmer. We need programmer or senior programmer or program manager. Maybe programmer, senior programmer for this program. So either it's related to the program or to the programming. For the test designer, test supervisor, and test technicians. And this resource breakdown structure is showing people only. So if facilities, material, money needed, then we can actually add those to the diagram. To estimate the duration of task, we need to understand the difference between the task duration and the work effort. For example, reviewing a document by an attorney requires 30 minutes, but the paper took 10 days to come back. The work effort is 30 minutes, while the task duration is 10 days. So when creating the schedule, when creating the diagram, we need to understand the difference between the work effort and the task duration. This chart actually shows the difference between the work effort and the duration. Also, the chart shows that 33% of employee or worker time is unplanned interruptions, such as replying at personal email, coffee breaks, bathroom break, phone calls, and socializing with other colleagues. When estimating task duration, we can either estimate hours of billable labor to complete the task or estimate the clock time required to complete the task. Actually, both are needed. The first one to bill client and the second one to identify the project completion date. As you might think, increasing the number of resources that works on a certain task will reduce the duration of the task. So if you have a certain task, you can assign 2 or 3 people to finish it faster. That's what everybody thinks. In other words, we are splitting the work between the involved resources. But that might be true until a certain point. After that, adding resources will crash the task and it will never be done, or it will not be done correctly. For example, to move a couch, you need 2 people. If you have 4 people or 5 or 6 people, that would be a lot of resources that assigned for this task and will lead to crashing point between the argument on who will be moving the couch and how they can get it out and so on. And that will take more time. Maybe the couch will not be moved at all. In addition, we have to consider the feasibility of adding more resources to a certain task. For example, it's not feasible to assign 9 surgeons to finish an open heart surgery in 30 minutes. It's not by adding more surgeons, because it's not feasible. They will not be able to work together just on one heart or to open the patient just for this surgery. Another thing that we have to consider is the communications overhead that will increase with adding more resources. Like I said, having 5 people, 6 people, instead of moving the couch, they are going to sit down and start communicating with each other. Who will do what? How can we do it? Is it going to be vertical, horizontal, and so on? So we are actually increasing the communication and the overhead of the communication by adding these resources. And that will all lead to a risk of not doing the job correctly, or delaying the job. So that will create a risk in project accomplishment. The duration of task is random variable, and usually to estimate task duration, you would like to be within the narrowest possible variance that you can. But why do we have variation to begin with? The reason for variation actually depends on the varying skills levels between the different personnel. And usually we calculate, if we need to calculate that, the duration based on the skills, we calculate it based on average skill. Also, it's due to the unexpected events, such as the incorrect shipment. If I receive the wrong item, then I have to ship it back and wait for the new item to come, and that will delay the execution of that process or that activity. The efficiency of work time need additional time to go back to the same level of productivity interrupted. Mistakes and misunderstandings, rework, and semi-completed work. And then the common cause variation, just the nature of variation. There are 6 methods that can be used to estimate task duration. The analogous technique, which is comparing the tasks to similar activities in previous projects within the organization. And the parametric technique, which is using statistical relations between the historical data and other variables, for example, the square footage in construction. Then we can also use the expert advice. A 4th method is a Delphi technique, which is a group of experts individually estimate duration. Then we take the average of the estimates of this group of experts, and we can repeat that again until we get the proper estimate. The 5th method is the 3-point technique, which is taking 3 points and average them, the most optimistic point or estimate, the most pessimistic estimate, and the most likely estimate. And then we calculate the average, and by calculating the average, usually we use a certain formula, and I will go through that in an example. And the sixth method is the wideband Delphi technique, which is combining the Delphi technique and the 3-point techniques. So we can take the group experts estimate and the most optimistic, most pessimistic, and most likely, then take the average of these two readings, and that will be the wide band Delphi technique. For the parametric techniques example, in the historical data, it was found that a resource can install 25 meters of cable per hour. So the question is, estimate the duration for a task that requires the installation of 1,000 meters or meter of cable. To calculate that, we need to look at the historical data. So if every 25 meters can be installed in 1 hour, how many hours do I need to spend or to perform to install 1,000 meters? The time or the duration will be 1,000 divided by 25, which is equal to 40 hours. So actually, the 1,000 meter of cable activity was not done before, but we did 25 meters of cable. So based on the historical information and the estimate of 25 meters that we got before, I could estimate a new installation of 1,000 meter cable. And I can estimate any kind of installation for such a cable if I can divide the number by 25 and calculate the number of hours needed to install that cable. For the Delphi techniques, if I have 3 experts, John, Jack, and James, the expert John gave me an estimation for the task duration 25 hours, while Jack said 19 hours and James said 22 hours. To calculate the expected duration for the task or the estimate for that task, we add all 3 durations and divide by 3, which will give me the average estimated task duration. In this situation, we have 25 plus 19 plus 22 divided by 3, and that will give us 22 hours. So the estimated task duration or average is 22 hours. For the 3-point technique, we have 2 tasks, task A, task B. The optimistic estimate for task A is 48, most likely 52, pessimistic 55. For task B, the optimistic is 36, the most likely is 39, and the pessimistic 43. To estimate or to calculate the expected time, the estimate time will be equal to T optimistic plus 4 T most likely plus T pessimistic, all added together divided by 6. So it's T optimistic, 1 T from the optimistic, and then we add 4 times T most likely, then we add T pessimistic and divide by 6. So it will be 48 plus 4 times 52 plus 55 divided by 6, and that will give me 51.8 hours. The same for activity B. It will be 36 plus 4 times 39 plus 43, all divided by 6, and that will be 39.2 hours. For the standard deviation, we subtract TP minus TO, T pessimistic minus T optimistic, divide by 6, which, by chance, for both activity A and B, it came to 1.2 hours. That doesn't mean that it will be like that with you. It depends on the numbers that you will have for each activity, but in this case, it came by chance that both standard deviation are the same. When estimating duration, you start with roughly estimate with the intention to improve the precision of the estimation or the estimates later in the project. Numbers are not 100% correct and could be changed, and customer must be informed of the possibility of these changes. So we should state that in the kickoff meeting or in the first meeting with the customer, that those estimates are rough estimates and might change in a certain way. But at the same time, although we have estimate, that doesn't mean that the task we estimated 1 week to be done in 9 weeks. It doesn't make sense for the customer that you tell them that the variation is big range. So actually, when we say variation, the variability here will be small variability within certain range, not to exceed certain limits. There are 3 variables that influence duration estimate: the duration, the total amount of work, hours per day, and the percent per day that person can devote to a task. For example, some people work 50% of their time on task A, 10% on task B, 30% on task C, and 10% maybe breaks. Or if we are going to use the 33% as waste time, then we have only 70%, and with the 70%, maybe someone would like to work 40, 20, 10, 40 for activity A, 20 for activity B, and 10 for activity C. So it depends on the percentage that each person dedicates or devote for that task. And some people will work 8 hours straight per day. Some have part-time job where they work only 4 hours per day. So it depends on these factors. The methods for estimating duration as a function of resource availability, it will be either constant percent per day. So we have 40 hours with just 50%. I will do half the job every day. Then it will be done in 80 hours. That's the total estimation or total duration of a task. We can assign as a duration and total work effort, which is 5 persons day. If we have 5 person days or five human days, that will be divided by 10 days, and that's 5.5 or half percent or half the work. We can assign as duration and percent per day. So we will have 10 days times the percentage that you work per day, which is half, and that will be 5 human days that for that task to be done. One other important thing that we need to manage in time management or in the schedule is the sequence of activities. So after defining the task duration, we need to define the sequence of activities, which can be defined based on the logical relationship between the activities. For example, in construction or constructing a house, you cannot install the drywall before the framing process. Then we need to use the precedence diagramming method to identify the type of dependency. We have 4 different dependencies that we can relate to: the finish to start, finish to finish, start to start, and start to finish. The finish to start means that the initiation of the successor activity depends upon the completion of the predecessor activity. Or the finish to finish, which means the completion of a successor activity depends upon the completion of the predecessor activity. Start to start, which means the initiation of the successor activity depends upon the initiation of the predecessor activity. The start to finish means that the completion of the successor activity depends upon the initiation of the predecessor activity. There are 3 types of dependencies that are used to define the sequence among the activities: mandatory activities or dependencies, which means it is mandatory for one activity to finish to be able to start the other related activity or activities, like we said with the construction example, where we have the drywall that cannot be installed before finishing the framing. We have discretionary dependencies. Those dependencies are referred to the preferred logical sequence, or if a specific sequence is desired based on knowledge of best practices within certain area. And then we have external dependencies, which involves the relationship between project activities and non-project activities. Those dependencies are outside the project team's control. We can actually mention an example, a good example for that: the testing of software, which depends on the delivery of hardware from an external source. So actually the project team does not have any control on that. Once we have all the information, and as a result of defining the activities needed to complete the project and estimating the activity duration and resources needed and identifying the sequence for these activities, we can develop what's called project schedule. So the project schedule will include the list of activities that have been identified to achieve project goals and objectives. It will include the activity attributes, including the duration of each activity, which will assist in identifying total project duration. It will also include the resources needed to accomplish each activity and the sequence of activities, and the project timeline or calendar, which will include identifying the need to work weekends or night shifts. To develop the project schedule, we can use the following tools: Microsoft Project, and we explained that in the previous chapter or session, and the Gantt chart, where we have the list of activities, their starting date, their finish date, duration, and the predecessors. And the other method is the network diagram and the critical path method, which will be explained in the next part of this chapter. That will be all for this session. If you have any questions, please email it to me. Thank you.